This is the lecture for Wednesday, the 15th of 2014. Let's start with a quick review of specific heat. Specific heat is the amount of energy required to raise the temperature of 1 gram of a substance 1 degree Celsius. So if we look at Table 2, we see water has a much higher specific heat than aluminum. If you have the same amount of each substance, it takes a lot more energy to heat up water than it does to heat up aluminum. So that's all we're saying. In fact, water is one of the highest specific heats that we know of. From this, we looked at the problems on the next page. Q is energy. It's measured in joules. And the energy is equal to, that an object absorbs or releases, the mass of the object times the specific heat of the object times the change in temperature of the object. So on Tuesday, you did a bunch of these problems in class, so hopefully this has gone well. To measure the amount of heat an object contains, we use an instrument called a calorimeter. And we use a process called calorimetry. So we measure changes for chemical and physical processes using a calorimeter. It's based on the law of conservation of mass that says that the heat that is released by a system is absorbed by the surroundings, the exact same amount of heat. It's carried out in an insulated container called a calorimeter. So in lab this week, we're going to use a calorimeter, a coffee cup, to measure the amount of heat that two different metals absorb. And from that, we're going to calculate the specific heat of each of those metals. The cool thing is, it's the exact same equation that we used for measuring heat. Q equals M times C times delta T. The difference is we're measuring the water inside the calorimeter. What the object loses, the water gains. So if we know the mass of the water, if we know the specific heat of water, and we know the change in temperature of the water, we can figure out how much heat the water absorbed. Well, the amount of heat the water absorbed is exactly the same as the amount of heat the object gave off. So down below, we're going to solve this problem. Q equals M times C times delta T. But in this case, we're talking about the water. So we have an initial temperature of 25.60 degrees. There is 125 grams of water. The specific heat of water is 4.18 joules per gram degree Celsius. And the change in temperature is 29.3 degrees Celsius. The final temperature is. So the change in temperature is 3.7 degrees Celsius. The water was initially at 25.6. We drop in an object into the water, so the object's temperature will go down, the temperature of the water will go up until it stops at this temperature. That's the difference between the initial temperature of the water, 25.6, and the final temperature of the water, 29.3. So Q is equal to Here's where those sig figs kind of mess with us. Here's the actual answer, but to round it to 3 sig figs, we would say 1,930 joules. But that's only one half of the problem. That calculates the amount of heat that the object contained. What we're going to do in lab is actually figure out the specific heat of that object. So we're going to skip ahead to page 9 and just review for a second a heating curve. If you look at the heating curve, the points I want to mention here are the areas where the object melts and the area where an object vaporizes. At these points, the temperature of the water does not change. If the temperature of the water doesn't change, then you cannot use Q equals M times C times delta T, because delta T would be 0, and you wouldn't, and your final answer would be 0. When we're at these two conditions, melting or vaporization or boiling, when we heat, or condensation and freezing when we remove heat, we have to use a different equation to measure heat lost or gain. And if we back up a page, it's called the heat of fusion and the heat of solidification. All solids absorb heat as they melt to become liquid. The temperature of the solid will remain constant, that's the horizontal, until the solid has completely melted. Only after the solid has melted does the temperature change again. The quantity of heat absorbed by melting solid is exactly the same as the amount of heat lost when the liquid freezes. The heat of fusion of water is the amount of energy needed to melt 1 gram of ice at its melting point. This value is 334 joules per gram. It's found in table B. All liquids absorb heat as they boil to become a gas. The temperature of the liquid will remain constant. Again, this is the flat part of the curve, until the liquid has been vaporized. Only after the liquid is vaporized will the temperature of the gas rise. The quantity of heat absorbed to vaporize is equal to the quantity of heat lost when the gas condenses. The heat of vaporization of water is the energy needed to vaporize 1 gram. It is not the same as the heat of fusion. It is 2260 joules per gram, and this is also found in table B. So if you are given a question at the melting point or the boiling point, you cannot use Q equals MC delta T. Instead, we have to use the equations that are found in the reference table on the back, table T. So why don't you get out your reference table really fast. So the second equations from the bottom, we see for fusion, Q equals M times heat of fusion, and for vaporization, Q equals M times heat of vaporization. So actually the questions are easier to solve because if you know the mass of the substance or the water, you just have to plug in the corresponding value for HF or HV. So we're going to, at this point, go to the calorimetry worksheet packet, and we are going to flip to the calorimetry, let's see, to the last page, heat of fusion, heat of vaporization worksheet. And we're going to do number 1, and I'm going to do mine in this space here. You can go ahead and do it in the actual packet. Actually, we're going to do question number 2. So this is one question, and then we're done. Heat of fusion, heat of vaporization worksheet, number 2. How many joules of energy are released when 250 grams of gaseous water condenses? Since we're talking about condensation, water is at that higher flat part of the graph. So Q is equal to M times the heat of vaporization. Q is equal to 250 grams times the heat of vaporization of water from table B, which is 2260 joules per gram. And when we solve, officially, we should be 2 sig figs. So 5.7 times 10 to the 5th joules. So that's how easy those questions are. So in class, we're going to do the heat of fusion, heat of vaporization worksheet tomorrow. We're going to do the calorimetry problems worksheet, which I'll explain in class. Have a great night, and we'll talk to you later.